let's go to the one-way ANOVA. I'm not completely sure if you covered this with Colleen. The way to think about a one-way ANOVA, though, is if you wanted to compare 3 or more means. So the independent sample t-test compares 2 means. What if you have 3 or more? So for example, let's see if the 3 training levels in the employee data set have different salaries. Well, what you do, as we did with PROC t-test, you specify the independent variable in the class statement, but GLM is going to use a model statement rather than a var statement. And you're going to say the dependent variable salary is equal to the independent variable. Now, by the way, this class statement asks SAS to create dummies, if you remember that from regression. One more thing, you might want to do a bunch of pairwise comparisons of means. You do that with this mean statement, specify means, the independent variable, and then tell what test you want to do. So Duncan groupings come out very nicely in SAS. If we go look at the output, the ANOVA table tests the overall hypothesis that all the means are the same against the alternative that at least one is different. The p-value is very highly significant. We conclude that at least one of the means are different. Then we go down to our comparisons of means, and it's really important to read the output carefully. So means with the same letter are not significantly different. I can't get the thing to highlight right. So what that means is I cannot say that training levels 2 and 3 have different mean income because they have the same Duncan grouping. They're both in group A, but I can say that training level 1 is significantly lower than training levels 2 or 3. So I've just done a lot of 3 independent sample t-tests in essence. Let's move on to regression. So how do you fit a regression in SAS? You're going to use PROC REG. So with PROC REG, you're going to use a model statement, just like we did with GLM. You say the dependent variables, however many you have, equal all the independent variables on the other side of the equal sign. So if we regress the overall experience at CPK on food, atmosphere, and service, those are those 3 factors, here's what you get. So you get your ANOVA table, you get your summary statistics, and you get the parameter estimates. Here's some other options that you may want to include. So if you do STDB, you get your standardized regression coefficients. VIF gives you variance inflation factors along with a tolerance. You get collinear diagnostics if you want. Here's how you do a stepwise regression. So those are all options that are often used. I mentioned in a previous lecture the where statement. So you can stick a where statement on any of these procs. And for example, if you only want to look at men only, so if you stick a where statement where Q16 equals 1, you get the means for only men. So that's a very efficient way. Be like select cases in SPSS. A few more things about PROC REG. Now, sometimes you want to do things like save predicted values and residuals. In SPSS, you go into, save and then predicted values, something like that. In SAS, you're going to add an output statement. So output, then one option you really want to specify is out equals. This is the name of the data set. So I'm going to make a new data set called CPK out. Then you have to tell it what you want, just as you did in means. So this output statement is almost identical to what you had in PROC means. Here, if you want the predicted values, here's the keyword for that, predicted. So I'm going to call my predicted values y hat. And I'm going to also ask for the residuals, and we'll call those e's. Now let's go print the first 10 observations. And so what you'll see is here is your dependent variable y. Here's the predicted value. If you take y minus y hat, you get the residual, or 12. And you can check the work and see that that's exactly what you get across the board. Okay. Another thing that you might want to do is save the predicted, the estimated slopes. So I'm going to save the slopes in a file called beta. Now let's go look at what beta looks like. Here is beta. So you get one line in this data set. It has the value of the standard error of the estimate, RMSE. Then you get the different slopes from the regression. And so that's how you use PROC REG. Let's move on. This is more from chapter 15. A one-way ANOVA is where you've got one categorical variable, like training level. Sometimes you want to control for other variables in the model, like age and experience. Colleen probably had you make dummies for something like training level at that point. You can do all this more automatically with PROC GLM and SAS. So you use PROC GLM, the general linear model. We used it for ANOVA. Put all variables that you want to dummy out. So anything that's categorical in a class statement, and anything you just want as numerical you list under model without listing it in the class statement. And there's any number of things that you can do. If you want to include interactions, you use the vertical bar symbol. If you want four-way interactions, for example, here's A, B, C, D all interacting with each other. That's how you do it. If you only want two-way interactions, you do this with an @2, and that only gives you the two-way interactions. If you want to interact a categorical variable with a numerical variable, you can also use the vertical bar sign. So these are all really useful things that you can do. How do you run a logistic regression? Well, you're going to use PROC Logistic. It looks a lot like GLM and reg. So you use a model statement. The dependent variables equal all the independent variables. The only thing that's really different, besides the name of the PROC, is this option, which is really important, descending. So what descending assumes is that no is less than yes. The default is to assume that no is greater than yes. So if you say descending, that just indicates that no is less than yes. So 0 was no, 1 was yes. So you need that option. Otherwise, Logistic will predict the probability of a no rather than a probability of a yes. All right. Let's move on to a couple of things you did in Colleen's class. You also did a factor analysis. So how would you run a factor analysis in SAS? PROC factor. And you give the data set as you would expect. The three options that I use most often are reorder, rotate, and fuzz. So reorder is the same as the sort option in SPSS, and that just sorts your loading, your variables, organizes them by factor, so it makes your output much easier to read. You probably want to rotate your factors. You probably want to use Varimax, so just do that. And then fuzz. What does fuzz do? Fuzz is this option in SPSS, blank 0.3. So that suppresses all loadings less than 0.3. It just prints a dot. It makes the output a whole lot more readable. So you'll see a note at the bottom of your output that values less than 0.3 have been suppressed. So that's what fuzz does. Colleen probably didn't talk to you about maximum likelihood estimation or other methods of estimation, but should you ever need to use maximum likelihood estimation, here's the option that you would add. How do you save factor scores? Well, to save factor scores, you need two additional options. So one is the n factor. N factor tells SAS, I want to save one factor or two factors, however many you specify. And then the out equals argument redirects the output, creates a new data set, in this case FA out, containing the factor score. So let me show you the results of running this. Here's what we get in FA out. We get our 5 variables that I factored, plus the factor scores. So that's how you save factor scores. You'll note that we have some problems with missing this third person left Q6B blank. For this reason, I tend to use the mean of function, because then SAS would estimate the mean of this guy as being 4 rather than leaving it blank as it does with proc factor. Finally, in Frank's class, you covered k-means clustering. So how do you do k-means clustering in SAS? You do it with proc fastclus. So proc fastclus takes a var statement, just as proc means and proc factor does. One option that you definitely want to use, you must set, is the max C option. So that tells SAS how many clusters you want. You probably want to specify the drift option. The drift option talks about, in SPSS it's called running means, and it improves the estimation usually. So I'd recommend using drift. And here's your output. And that's, well, actually there are a few more options down here you may have learned about. So converge sets of convergence criteria. Now it's your turn. I've just listed a lot of problems in Siegel, so a lot of problems from chapter 9 and 10. You've got the answers to all of these in your course packet from fall. Likewise, those from chapter 10. Here are the ones from chapter 11 and 12. And if you flip ahead, I've given you my answers to those. Actually, they're not appearing, but they are in your version of this file. This last problem, actually the CPK one's nothing profound. It does give you some practice with factor analysis and logistic regression. This last problem's a bit harder, and I don't expect you to do it, but I left it in the course packet nevertheless.